Hello and welcome to another video, and today we have an Asus board, a Strix B550 A gaming. I do not remember what is wrong with this board. I got this board quite some time ago and I forgot to write down what was wrong with it. So once upon a time I knew with which problem this got to me, but I do not anymore. So we will figure it out together. And yeah, on AM4, I just like to instantly go in with a CPU and see for the power consumption. This being B550, I would go with the 3000G because the many of the 500, the 500 series, like B550 for example, or X570, they often don't have supports anymore for 2000 series processors or similar like that. They can have, but they don't have to have that. So let's get some postcards also into here. There's also the option of a flying lead with the Asus.com debug right here. So there's a COM debug header where you take pin 1, which is down there, and you plug it into pin 1 of the PCIe postcard in order to get postcodes on the TL postcode analyzer. So let me show you that. If we can get actual postcodes out of this now. Okay, so the board is built up. Let's now see for its passive power consumption. We have 220 milliamps, which is kinda high, but it might be fine, but I would expect it to be lower than that. Let's now get a power button onto here. Let's see if it reacts to the power button. Whoo! That just popped big time. Holy shit, that scared me. If I'm not mistaken, I just saw 40 amps right there. This seems to have a major short somewhere. Holy moly. That scared the shit out of me. Oh, okay. Well done. That probably just destroyed my adapter. Let's get the... let's see for some shorts on the 24 pin. Maybe we should do that first. Let's see now. Okay. We have... Is this low resistance here? No. No short resistance. I'm checking 3.3 volts. Let's go in a higher range then. 3.3 volts. This is, I think, 5 volts. 250. 25 ohms on like 5 volts probably. Let's see on 12 volts. It might be reversed. It might be the 12 volts that has that little of power consumption. Question is this thing shorted? Let's try to turn it on. It is not shorted. That is very good to see. So this thing is not shorted so far, because it doesn't draw just amps. Let's see if I turn this on. Also not shorted. Question is my build up thing shorted? I might have destroyed my setup, but I will have to deal with that later. Let's now see for what is shorted here. So on the top right pin, the second one on the right row from the top has low resistance. So we saw something like 25 ohms right there. 10 ohms, 12 ohms. Yeah, something very low. Let's disconnect everything. And let's now We probably have to get the heatsinks off of here, because we will have to inject voltage and see then. So let me get the heatsinks off of here. So I just had a quick look. The shorted line that we have seems to be a 5-volt line. So what we're going to do, we're going to go for 1 volt of injection into there, and then see, sadly, 5 volts is a rail where a lot of major stuff is on, and where a lot of things can happen. Especially when 5 volts die, you very often have all of the USB devices die, which is a hassle to replace them. But we will see. So let's hook up a ground lead. I often like to use something around the USB connectors, and then I will take tweezers, and let's see, I will put, let's see, it takes 300 milliamps already when injecting that. Okay, let's just heat it up, and let me get my thermal camera. So the camera is set up. Let's now see if we can find anything actually heating up. We do have something around the VRM right there, but nothing else. Let's increase the voltage a little bit. We go to 3 amps, 3 volts, and now we can clearly see that we have something at the top there. Seems like it's DR MOSFETs that might be shorted. That might have also explained why there was such an overcurrent situation at my supply, because we might have just shorted the 12 volts directly to the CPU in this case, maybe even. So you can see very clearly. Let's see, let's zoom down on this. Now you can see very clearly 2 DR MOSFETs and a resistor close to it. So that is the short that we have on the 5 volts. Let's now then check if our 12 volts actually has a short circuit as well, the CPU line. So let's see for the 12 volts. So the 12 volts isn't directly shorted, as you can see. It's going down though. And let's see if the 12 volts is like shorted to the phase. Yeah, but that is the case. So the 12 volts is shorted to the phase directly, as far as it seems. Pretty sure. So yeah, so it's probably these 2 DR MOSFETs that we have to take off, and then we can see again. There are 2 big capacitors here that I want to remove before hot airing this area, because it will take quite some time to remove those DR MOSFETs. So let's first remove these 2 capacitors. And I've shown this before in a video. It is very easy if you have the right soldering tips. So what I'm using is this tip right here, a big knife's edge. And what you then do, you just grab some solder and some flux. Let's see, are these the same? Just for the orientation, ground. So the stripe goes to the outside. So just check the orientation, and they're both the same, and they also have both the same value. So now what we do is we take our soldering iron, our big tip. We're going to heat both of these joints up, and there's the cap also already out. Doing the same for the lower one now. And that cap is also out. So now we have protected our capacitors. So as you can see, if I can show you right there, there's cap 1, and we have another cap right here. So let's put these to the side, and now we can focus on hot airing these MOSFETs off of here. Let's see now if we can actually visually see something wrong with them already, but it doesn't seem to be. So it was these two that were heating up. And it was also that 2.2 ohm resistor, which probably isn't 2.2 ohm anymore. So let's see for that. If these still... Nope, they are not 2.2 ohm. Let's go in a higher range. Okay, I still don't get a reading off of these. How high did they go? No, now I get a good reading. And let's see this again. Oh, they are fine. 2.2 ohms. You know, like 2.7, but that is with probe resistance. And on the higher one, on this one, also 2.2. Interesting. So they did survive. Good to know. But the DR mosses have to go. So this will probably take a lot of hot air. I might want to use a preheater actually, because this will take forever if I don't do that properly. I think I might manage. I think I will manage with just hot airing it off without using a preheater. But using a preheater would definitely be the right choice here because, yeah, let's just do it. Because these are DR mosses have quite some heavy planes. So it will take quite some heat, localized heat, to get them off. So let's just do it the right way. Get the preheater out. Preheat that area to maybe 100 degrees or something like that. So it will be easier for us to take these off. So let me set this up correctly. So the microscope will be very far in now because the whole assembly is propped up and I cannot prop my microscope any further up. So I will be starting the preheating process, and this will be a time lapse, pretty sure, of me trying to take these off. So, see you then. So, board is preheated, 420 degrees on my hot air, and I will now be blasting off these DR mosses. So they're removed really easily now, but one of those DR mosses just held on to the 12 volt plane here, but I think it's fine. It welded itself a little bit to it, but I got it removed. Let's go under the microscope again, and let's clean up the area. So this cleaned up very nicely, or it took off very, very nicely without too much hassle. So let me now get the soldering iron and just remove most of the solder that we have here. Especially while the board is still very hot. So this is clean. And here you can see the bottom left pad is a little bit ripped from the board. That is where one of the diamos is definitely welded on. But we got really lucky in it not actually charring, but I was able to remove it. So now it cleaned up nicely. We have most of the solder removed. We could already add leaded solder here, but I want to now first clean this area up. So get rid of all of the flux. And when having done that, we will take some measurements next and see if the shorts removed actually now. And yeah, go from there based on the measurements that we get. So we have the two DR mosses in front of us now. Let's go into continuity mode. And let's now check. So we get beeping when these are connected. And I think this is I think the output, and is this the input? So it's not shorted from the 12 volts as I would expect it to. Let's see on this one. So the only short I can see is between these two pads. So what I would expect between the output and some of the inputs to be a short, and with this being the output, this long strip here, but that is not the case, as you can see. So let me get a board view and actually see how these work, what these two pads are here, this one and why these are showing a short. So this seems to be a 50 amp power stage. This might be not the correct one, but this is basically it. It was from a similar board, and we have a short between, oh no, these two are ground. Okay, so these two are supposed to be the same. So I would have expected to have a short between this pad here and these ones. Interesting. We might be shorted through this here, through this switch, because that was the 5 volts, I think that was getting hot. So, pretty sure that these two were bad. But I would have expected a short between there and there. Let's now take measurements of the board and see how that now reacts. So, we have the board now. It's cooled down again. Let's now go into resistance range and do the same resistance reading again. So, we're going to take a ground and we're going to go into the 5 volts. And we still have low resistance on the 5 volts, still 7 ohms. So we still have something more. Let's see if the 12 volts is still shorted now. So we didn't have a short like this, but we did read a short to the phase. And now we do not anymore. So the short on the 12 volts to a phase is now gone. We now have kilo ohms through that, but we still have to find out why our 5 volts is shorted, and it might be the PWM controller that is dead on this board. So let's now inject 5, maybe 5 volts. Let's start with 3 volts and see how, if we can already see anything. You could go very sure and just start it with like a single volt again, but we have done that before. There's no catastrophic power draw off of this. So yeah, we're going to be starting with 3 volts in here, and it's 500 milliamps. Let me get the thermal camera again. So let's see now. The general area is very hot, and we still have 2 more DR mosses. That is very bad. Okay, as you can see, we have 2 more DR mosses that didn't like whatever happened to them. As you can see, you cannot see. There. Now you can see. If my ring light wouldn't reflect so much, let me turn it off quickly. You can see right there that the Amos is still shorted. That one is probably also shorted, and that one is shorted. The other ones don't have any heat signal. This one might also have it. Man, really? That one to the right might also be damaged. So it might be only a single one right there that have survived. Let's see on this side. All of them look fine. So on the left side. But here, every single one except that one shows heat signature in the same area. That might be fine, but it's probably not. These 3 are definitely damaged. So more DR mosses to remove. So we definitely have to remove this one, and we probably also have to remove every single one here, to be honest. I might want to leave that single one. That single one I want to leave, and the others I'm going to all take off. So let me do that. And that means, yet again, getting the preheater out again, preheating this board again, and yeah, you've seen me do the procedure before, so let me do that. Board has been slow cooking again. And now I will be taking my hot air station again, same settings for 20 degrees, 90% airflow, and I will be blasting these off again. So as you can see, that was a breeze. That is what preheating does for you, taking these off. So now turning the preheater off again and getting it removed from our bench so that I can easily clean this board up. So let's get the board out of the way. Take the preheater off of here. Let's get the board into here again. Yeah, let me go under the microscope and quickly clean off the solder pads as long as the board is still hot, so that we don't have to struggle with that later if we are going to rebuild this board. This is going to be a big if, because the big thing is the PWM controller alive? This will say if this board has a chance to survive or not. So now all of the arm mosses are removed except a single one. And we will have to find out if I regret not taking that single one off and if I will have to do just that in a second. Yeah, now you can very clearly see on these ones that I cleaned that this pad and this pad is connected to each other. That is easy to see now. And these two are connected also. Yeah. Okay, now, so only this one is actively on here now. Let's see now if we still read a short circuit. Damn, that was hard. On the 5 volts on the auxiliary of the 24 pin. And yeah, so let's see now. I'm getting a ground and 5 volts. And that is higher, but maybe not high enough. Let's inject 5 volts and see if that DR MOS also heats up or not. If maybe that single one survived. Because now we're going for the actual how this rail will be. And I see some stuff already coming alive, which is a good sign. So let me get my thermal camera. So you can see the indication coming alive for the 12 volt missing. So let's see now. Yeah, this one might be shorted as well. If we plug this in, let's go closer to the phone. If I look right there, it still looks like it is shorted. It's 41 degrees, so I wouldn't trust it. With all of the other ones being dead, I wouldn't trust it. These ones on the side, on the left, look all fine. I can't see any heat signature like that there, but on this side, definitely. We will have to remove that one as well. Just to be sure that we now don't have a short anymore, and we're not going to kill anything further. So another thing I want to check is this PWM controller. These very often get fed by 5 volts, and there might be a resistor that is limiting the current to it. So we will have to find out where the 5 volts comes into this one and see if that is also shorted. So let's see in a board view then. So this is a similar board, a B550 A gaming, and this has the exact same controller. And pin 28 carries a signal that goes to a 2.2 ohm resistor here. This one, was it this one? That one. And this is connected to the 5 volts on the other side. So we will have to find pin 28 and also find this 2.2 ohm resistor and see if this PWM controller survived or not. And the arrangement here on the board is almost the exact same as on the other board view that we've seen. As you can see, this is pin 1 right there. Then we need to go to the third side and the second pin, which is this one right there. And then you follow the trace. It goes to this capacitor and then to this 2.2 ohm resistor. And now we want to see the resistance, and the resistance looks good. That is very great, because that means our PWM controller is not shorted on the 5 volts line, which I would have expected it to be. There's also a 12 volts. Let me quickly see which pin that is supposed to be. So it's supposed to be pin 18 if I'm not mistaken. Let me check again. It's pin 18, yep. It's the 4th, maybe the 5th from the top. Let's see now. It's supposed to be also connected to 2.0 ohm resist, 2.2 ohm. 1, 2, 3, 4, 5. Yeah, this one. And 12 volts also has high resistance. That is very good. So the PWM controller is not to blame, which would be great, because replacing those de-armors shouldn't be a problem. I think I have these in stock on some of the donor boards I have. So what we're going to do now, I'm going to be first prepping new de-armors. I'm going to be sourcing them in order to take off that one remaining de-armors that we have here, and then instantly place new ones. And I will also be adding leaded solder to all of these, so it's easier to solder the new ones on. But first, I will have to now go around my donor boards and find these de-armors. So let me do that. So this repair just does not want to get better for me. I just lost a lot of footage, sadly, because my PC crashed. So what have I done? I have removed the last phase. So all of these 7 phases are missing. There are 2 SoC rails right here, and the rest is a V-core. So these all don't heat up when you insert 5 volts. So none of these got shorted. And all of these ones are now removed, and they were damaged. Also now, we've checked the resistance of the PWM controller. 12 volts and 5 volts is not shorted through it, which is good. And what I've done, I've checked the 5 volts right on my adapter, and that adapter, the 5 volts there is good now, and also the other auxiliary ones. And we also don't have a short anymore from 12 volts to the V-core phase. So all of that has been taken care of. None of that is a problem anymore. Now, I've lost quite some recordings also of me taking off the BIOS chip and trying to flash it, because this board has onboard flashing, but that did not want to work. So I wanted to be sure. I took the BIOS chip off and tried to flash it, and that was successful. The BIOS chip read no problems. And yeah, I want to show you the result of that. We currently have a 3100 on here, which is definitely supported. So I want to show you that. Let's see, can it focus here? Okay, it wants to focus on my adapter, but we want to look at those LEDs right there. If I now get my power supply, my lab bench power supply, sadly you won't be able to see the current this time. We have 200 milliamps again of power consumption. And if I now press the power button, you can see we have DRAM LED, and it's going nowhere. We have 770 milliamps of stuck power consumption. We start off with somewhere around 2 amps of power consumption. But yeah, the board gets stuck. And this is not a DRAM LED, this is actually a CPU LED. So the CPU initialization has a problem on this board, which makes sense with having so many phases missing, because some of those phases might be responsible for startup. And if we now get a different CPU, let's for example take a 3300G. So if we start this up, we have 2 amps, 2.6 amps of power consumption, and 0.8, the LED went out. And there's nothing, no activity anymore. 0.8, and that's it. I do also have something on my tester right here. Let me show you that. So currently we have 2, 1, and we have the LED of DRAM and reset, which is stuck. So if we try this again, reset is being taken off, and then reset is applied again, and we are at the DRAM LED. I have tried many different sets of RAM and also on different positions. Like if I now take a different DIMM and place it in there and also take a different position, we basically end up at the same thing. And again. And the problem is we have stuck power consumption, 640 milliamps. All of the DRAM powers are there. I have checked that. So we're not missing any of those. Our voltages seem to be all there. It's just something about CPU recognition. And I want to be honest, I don't want to continue with this repair anymore. At some points, you need to call it quits. Like, I've considered the pros and cons of this, of going further. But one of the problems is I do not have these DR MOSes. These DR MOSes, for if I would want 7 of these off of AliExpress, I would pay over $30 for them. That is a lot of money for chips that are used probably from AliExpress, and you don't know if that will fix the board actually, because we don't 100% know if this PWM controller survived or if other things on this board did survive. One more thing is, I've already killed this one. This is my adapter that I've been using for the past few times, and I've killed this one already. I don't know if my 3000G survived. Then also for this board, there's also the 24-pin connector, which is damaged. I don't know if that was from preheating or when the high power consumption went in there, that at least one of the pins, the 5-volt pins, are broken. So that one isn't there anymore. So the 24-pin would also have to be replaced on this. And yeah, so this repair has got me stoked. Like, it is my own fault. Like, something similar happened before. And I said to the people, yes, I'm going to put a fuse into my 12-volt socket. And I didn't. I still forgot to do that. I need to do that. Because also, my little power consumption meter is also dead now. Because that doesn't work also. So yeah, I'm going to cut my losses here. I will need to put a 20 amp fuse into the 12-volt line there. Because the biggest problem is the power supply that I'm using is 100 amp. So that's a 1200 watt 12-volt power supply. It delivers a lot of amps. And if you had a look at the view of what it was in the moment that it blew up, it showed almost 41 amps at 6 volts. That is a lot of power. That is insane amounts of power. Like, what is 6 times 4? 24. And then times 10, 240 watts? More probably, right? No, 240 watts, yeah. 240 watts, just like that. At 6 volts, 6 times 4. Yeah, 24, and then, yeah. 240 watts, just like that in a second. With 40 amps, that is a lot. And with all of these things coming together, this board is going to be a great donor board for me, because I'm currently running low on good donor boards to take parts from, and this will be a great addition to my donor boards with all of these DR MOSes if I need any of them in the future, and with all of the other components on here, I will be using that. I know that, for example, the Aura chip that is on here, the RGB controller, that is really hard to source, and that also will be a great thing for my donor boards. And yeah, I'm just going to cut my losses with this board. Is this repairable? I'm not too sure, to be honest, because I don't feel like just replacing those phases would fix the problem that we currently have. It might go into a protection state currently, but I think there's another underlying issue here, which might be the PWM controller, which is also a reason why I'm not continuing on this, because I cannot be sure. And you won't always be able to fix everything. If this would be a viewer's board, I might be inclined to, but this board is mine. I have bought this out, and I don't really care anymore. This board has taken so much from me. I'm just going to trash it and use the parts as a donor, because I will now have to figure out quite some other things to repair, to be able to continue my usual repair. Yeah. So I hope you still learned something. Protect your 12-volt circuits, or maybe just check the for shorts first. Maybe I will do that and continues in the next videos. Maybe not. Who knows? It's kind of the fun of it, having things like this happen also. And yeah, do as I do, do as I say, not as I do, as you would say. So I hope you enjoyed the video. Thank you very much for watching. This was Mainboard Medic. All of my tools are linked in the video description as always. Thank you very much and goodbye.